Hello and good day. My name is Corey Amanda and this is my proposal presentation on removal of azo dyes by using bubble treatment. Let's get started. Azo dyes make up about 70% of synthetic dyes used in the cosmetic, plastic, textile, paper, food and rubber industries. Removing of azo dyes color in the treatment of textile dyeing and dye manufacturing wastewater is a major issue. Around 70 million tons of artificial dyes are manufactured annually for the textile industry worldwide, with about 10% of the dye stuff being discharged to the surrounding as processed wastewater. Let us dive into the history of textile industry in Malaysia. The textile and garment industry in Malaysia is one of the country's most well-established manufacturing industries. In 2017, the industry directly employed over 90,000 people and the export worth $3.3 billion. The Malaysian government has high aspiration for the industry, with a $6 billion export target set for 2020. One of Malaysia's very well-known textile industries is batik, which reported to be worth between 370 and 400 million ringgit Malaysia per year. Textile dyes degrade the aesthetic quality of water bodies. It is extremely toxic and potentially carcinogenic, resulting in environmental degradation and a variety of diseases in living things. Textile dyes changes the pH, raises the biochemical and chemical oxygen demand, and causes intense coloration. Treating dye-containing wastewater before final disposal is important to meet international requirements and protect natural biodiversity. Bubble treatment is also known as ozonation process. Ozone was first used for water sterilization in 1893. The reaction of ozone with organic or inorganic compounds in aqueous media has gained a range of treatment goals. Ozone has developed as an environmentally friendly oxidant and disinfectant. Traditional biological processes cannot effectively decolorize synthetic dyes. To avoid soil pollution, surface and groundwater, dye contamination wastewater discharged from textile and other dye stuff industries must be treated. Adsorption, coagulation, electrochemical degradation, and photocatalysis are commonly used to treat dye effluent. However, this method has several limitations. The objectives of the study are to investigate the characteristics of azo dyes in wastewater, to evaluate the process of bubble treatment in removing azo dyes, and to utilize the effectiveness of bubble treatment in the removal of azo dyes. All the experiments will be performed at room temperature. Ozonation of dye solution was carried out in a batch mode. The solution for synthetic azo dyes will be made by dissolving the dyes in millicube water. Before entering the ozone generator cell, oxygen will be fed to the ozone generator. A rotameter will be used to circulate the oxygen gas. UV-vis spectrophotometric technique throughout the wavelength range of 250 to 1000 nanometer will be used to measure decolorization of dye samples. The iodometric method will be used to calculate the amount of ozone emitted and consumed. COD and BOD measurement will be used to determine the degree of mineralization of the dye samples. This study will provide a better understanding of how bubble treatment can help in removing azo dyes in wastewater. This study also aims to utilize the effectiveness of bubble treatment in the removal of azo dyes. With the rising cost of pollution monitoring, control, and elimination, there is a need for a cheaper method of pollutant removal. Thus, an inexpensive method of dye removal is preferred, which is bubble treatment. Finally, this is the work plan for the study. With proper time management, the study can be completed within the schedule. With that, I end my presentation video. Thank you.